Describe the long-run behavior of each of these power functions. The quadratic function f of x equals x squared, the negative quadratic function f of x equals negative x squared, the cubic function x cubed, and the negative cubic negative x cubed. And these four examples will be these are sort of fundamental examples showing the four different end behavior combinations that are possible for any power function, or in fact for any polynomial, just based on whether the degree is even, as in A and B, or odd, as in C and D, and then depending on whether we're positive or negative. So in this case, we just need to think about what these graphs look like, their basic toolkit functions or reflected versions of those. So y equals x squared looks like this. And then the end behavior questions are twofold. We want to know, as x goes out to positive infinity, what is y doing? And with a polynomial function, it's either going to positive infinity or negative infinity. Those are really the only two possibilities for the end behavior of any polynomial. So as we go out the positive x-axis in this direction, we notice that the y values corresponding are going up, and so that's the answer, and that's our description of the end behavior in that direction. As x goes to infinity, y goes to infinity. Now go back the other direction. As x goes to negative infinity, back this direction, the corresponding y values are still going up, and we say so then y is going to positive infinity. So how does that change if we look at y equals negative x squared? The graph has the same form. It's now been vertically reflected to open down. So that's y equals negative x squared. Let's write its end behavior. In this case, as x goes to positive infinity, the y values are going to negative infinity. And as we go to the left out the x-axis toward negative infinity, the y values are again going to negative infinity. Now let's see what the cubic functions look like. First, y equals x cubed. Cubic toolkit function. And we see that as x goes out to positive infinity, the y values are headed to positive infinity. That's the end behavior in that direction. But as we go to the left, as x goes back to negative infinity, the y values are going down. So as x goes to negative infinity, y goes to negative infinity. And finally, we just look at that reflected version of that. This is y equals negative x cubed. Graph has the same form, but it has been reflected vertically, and so the end behavior now is that as x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to positive infinity. And so these four examples are important, and they illustrate the four basic possibilities for the end behaviors of power functions or polynomial functions more generally.